McWong International, a 30-year-old company. We've been in sensors and controls for about 10 years. We're a manufacturer of a qualified mesh solution with sensors and controls, and an early adopter of Bluetooth. But I'm here today, of course, not to talk about our products, but to talk about the technology of Bluetooth and the promise that we see for the future of Bluetooth. A quick overview. I'm not going to go into a lot of technical details today, but I've come here today with basically two goals. The first goal is, if you've previously dismissed Bluetooth as a home-only automation technology, I hope to sort of disavow you of that belief, or at least encourage you to consider Bluetooth for commercial IoT. My second goal, if for whatever reason you've already chosen a technology for commercial IoT other than Bluetooth, I hope to encourage you to consider that any lighting retrofit moving forward today has a place for Bluetooth, even if you've chosen another core technology for the commercial lighting controls. So first, a quick background on Bluetooth. Bluetooth is already a 20-year-old technology. It's controlled and managed and stewarded by the Bluetooth SIG, the Special Interest Group. The Special Interest Group is a nonprofit trade association, very market-oriented. And what's unique about Bluetooth compared to other technologies is that the Bluetooth SIG actually controls all levels of the technology, from the physical layer, the radio itself, all the way through to the application layer. And that's quite important, and I'll discuss that in more detail later. Bluetooth is also a bit unique to some other technologies in that it is a truly global standard. 92% brand awareness around the world, and what's now, I understand, over 34,000 Bluetooth SIG members are pretty evenly balanced from the Asia Pacific, Americas, and Europe. This slide shows a brief overview of the Bluetooth technology itself. We all sort of got to know Bluetooth based on this technology on the far left, which is generally called Bluetooth Classic and is still widely used, and it's the basis for audio streaming technology. I'm not going to talk really about that today. I'm going to focus more on the Bluetooth low energy radio. The topologies here are important also, and I'm going to talk more about the Bluetooth specification for mesh. And what's interesting on the topologies here, as you move to the right, the mesh technology can also do broadcast and can also do point-to-point. And so that's important as well for the multifunctionality that's built into Bluetooth. Around 2010, Bluetooth SIG introduced the Bluetooth low energy radio, which significantly extended the capabilities of Bluetooth and introduced over what was previously a one-to-one communication protocol, the one-to-many communication protocol, and developed this broadcast capability. That technology basically started the first commercial use of Bluetooth in the form of what's generally called beacons, also referred to as location services, proximity services, RTLS. And there are different ways of looking at this and different applications for the technology, but it opened up sort of three very important use cases. The first is point of interest information, and that's being used broadly now across the world in museums, airports, and the idea there is that with a Bluetooth beacon, the beacons can sense the proximity of someone holding an app in their phone. Bluetooth is natively supported by 100% of smartphones manufactured today. The second use case is what's called navigation, indoor navigation or wayfinding. That's becoming more popular as well. That's basically the indoor equivalent to the GPS that we've all come to rely on for outdoor navigation. And the third use case is generally termed asset tracking. And that's where a Bluetooth tag can be attached to a high-value asset, and that can be tracked around, for example, medical carts in a hospital, wheelchairs in an airport, for example. Fast forwarding from 2010, when the Bluetooth low energy radio was introduced, in 2017, the Bluetooth SIG formally adopted Bluetooth Mesh, which is very important and really critical for any commercial IoT network. Bluetooth Mesh introduces or extends what was previously in the original Bluetooth low energy radio a one-to-many broadcast, and extends that to many-to-many. By design, by the architecture, it was designed really for large-scale network devices. It's ideally suited, we believe, for commercial lighting control and building automation. And there's much debate about that. We have been exploring different network technologies for over 10 years, and we have yet to see a technology in action that's more suitable from our standpoint for building automation. Talking a little bit about, and again, I won't go into the details here, the Bluetooth Mesh specification is almost 1,000 pages of documentation. And it's made up of 3 complementary specifications. And I want to point out just one here, the second specification, the mesh model specification, over 300 pages, and half of that is devoted to lighting. And so coming from a lighting background, I think we could all appreciate the detail that went into the specification and surrounding lighting. And that involves really almost any parameters that can be measured by a third-party lighting test lab. Those are all spelled out in the specification. So whether that's the Planckian locus, the blackbody curve, CRI, luminous intensity, luminous efficacy, it's all spelled out in the specification, which means it can be monitored and controlled with Bluetooth Mesh. So what do the specifications mean in action? First of all, Bluetooth Mesh is interoperable by design, and that the Bluetooth SIG has leveraged 20 years of the interoperability that we've all come to rely on from Bluetooth Classic into Bluetooth Low Energy. And so you can be sure that when you buy a qualified Bluetooth Mesh product from one vendor, it's going to be interoperable with a product from another vendor that's a qualified mesh product. That's important, and they do that by means of rigorous qualification, and also the fact that, as I mentioned earlier, all layers of the communication stack are specified, including the application layer, which is critical for interoperability. Bluetooth is secure by design also, as secure as anything we've seen out there in wireless. Provisioning is done with OOB authentication, which is out-of-band authentication, similar to what a lot of financial institutions use, where the authentication is done on 2 separate channels. Messages are all encrypted and secured, and sequentially encrypted so that there can't be replay attacks. And what's interesting and unique about Bluetooth as well, as far as security goes, you have the option with Bluetooth Mesh of not connecting into your IT infrastructure. Doesn't require a server. It can be a standalone network system. Bluetooth is also, by its architecture, scalable by design. There's no central point of failure. It's a broadcast system, also called flooding. But in this case, it's managed flood, which a managed flood means basically that the messages can only be repeated a number of times. There's a time to live indicator on the messages, and nodes that are set up to relay will not repeatedly relay. The other key to Bluetooth Mesh's capability is that the messages are very short and the data rate is quite high, as 4 times as high as some of the competing network technologies. And so what that means is it takes only about 400 microseconds for an individual message in Bluetooth to be transferred. That cuts down on packet collisions in the network, it cuts down on latency, and you don't see the popcorning effect that you see in some other topologies. So what does this mean for us here in the Property Technology Conference? There are a few different areas here that we can talk about. As I mentioned earlier, 100% of smartphone devices natively support Bluetooth, which basically lowers the cost of controlling and commissioning a network system. Bluetooth qualified mesh requires a security system, and so you can be sure that 100% of those devices that are Bluetooth mesh qualified implement this security. As far as the other benefits of Bluetooth, ABI research expects a 12-fold increase in asset tracking devices over the next 4 years. And that's, again, important that Bluetooth can serve this multi-function role. I thought I'd share just a few examples of Bluetooth implementations, Bluetooth mesh implementations. The first is the Van Gogh Museum in Amsterdam. This is interesting because it shows one example of interoperability. Zakato sensors and Ocean switches all working together. And there's something like 600 different works of art in the museum, and so you're coordinating the lighting, you're gathering sensor feedback from those areas in terms of humidity and temperature. So it's one example here, and in addition, it shows the multi-functionality where there's also wayfinding and also point of interest information. So as you walk through the museum and stand in front of a piece of art, you're getting real-time information on that particular piece of art. Here in London, Westminster Abbey, I understand in 2016, I believe that should have been. In any case, that's another example of interoperability. 250 luminaires controlled, and it's an environment that you wouldn't generally think of as very conducive to radio frequency technology. Gatwick Airport as well makes use of Bluetooth technology. 2,000 Bluetooth beacons in the Gatwick Airport. Unfortunately, my colleague Arthur and I passed through Gatwick Airport 2 days ago, and we were running to catch a train, and I forgot to open my, my phone to check out just what this wayfinding is all about. But also Bluetooth is not only applicable for retail and commercial and office applications, there are more and more applications in industrial settings. ABB is making use of Bluetooth technology and smart-enabled sensors to do preventive maintenance, and I understand this has reduced downtime on machinery by up to 70%. So a discussion of Bluetooth also wouldn't be complete without talking about Bluetooth 5. And Bluetooth 5 actually came out in 2016, the year before Bluetooth Mesh, and significantly expanded Bluetooth capabilities. Now, Bluetooth Mesh was introduced to be downward compatible with all the Bluetooth 4 and Bluetooth 4.x devices out there, which are literally over 1 billion. Bluetooth 5 is very important because for multiple reasons. First of all, it allows the user to optimize the radio. They can optimize the radio depending on the application, and they can choose to extend the range by up to 4 times the range of Bluetooth 4. If it's an indoor application with very dense nodes, they can instead increase the data capacity. They can increase that up to 2 times, in other words, 2 megabits per second. That's important for further improvement of network traffic, reducing the traffic jams, so to speak, reducing the packet collisions. So that, in turn, offers better performance in high radio traffic environments. We believe with Bluetooth 5, as it extends into the qualified Bluetooth mesh, we will begin seeing not only large-scale commercial indoor applications, but applications that will also include the exterior lighting together, all on a unified platform. I wanted to talk a little bit also about return on investment. You know, the past 10 years or even going further back, lighting retrofits were focused on energy savings, and really energy savings alone. The McKinsey Consulting Company put out a report in October talking about this sort of step change, this leap in return on investment considerations, and how we're going beyond the simple energy savings paradigm. And this is really opening up, and many of us have been also talking about human-centric lighting. We're taking a look at the link between working environment and a positive employee experience. And Bluetooth Mesh can enable that. Predictive awareness of individual needs, bioadaptability of the environment. But the benefits accrue not only to the employees in a facility, but also to the owner, operators, facility managers. Because the building can self-monitor, you can save money on predictive maintenance and preventive maintenance. What's potentially even more important, and I know there have been a lot of discussions here at LuxLive this week, a lot of folks who are very keyed into this, and that's opportunities around emergency lighting and occupant safety in a building. And that's, I think, where Bluetooth can really shine as well. Combining beacon technology together with sensors, you can achieve some really interesting benefits. Whether it's access control, dynamic egress guidance, so that if a particular exit point is blocked by smoke or fire, the lighting could automatically guide occupants toward another exit. First responders could also get more information on where in a building the occupants still are. That's particularly important for multi-story, high-level buildings. So just some sort of images here to show sort of what was yesterday's smart buildings and then today's smart buildings, where we start to see opportunities with Bluetooth Mesh to add on HVAC controls and window coverings, indoor navigation, all on one platform. So inspired by all that we're seeing around us in use cases, we normally sell our controls to luminaire manufacturers who then install them, and we're far away from the benefits, so we've decided to retrofit our own offices using not only our own products but competitors' products as well to demonstrate the interoperability. What we want to demonstrate as well is that with Bluetooth Mesh, the ease of planning and commissioning is very important. And so we're going to show how through a multi-phase approach you can implement Bluetooth Mesh in a commercial building. You don't need to tackle the whole building at once. So we've started already with offices. We're moving to warehouses next month, and then we're going to expand it across the entire office. And so we invite you also to partner together with others to do case studies and really test out how far can Bluetooth Mesh take us. With that, I thank you and welcome you to visit Bluetooth.com. an amazing amount of resources there. Thank you.
Okay. Thank you, Blane.